of alpha is the sine of beta. That's what it means they are complementary. It's a property that can be proved. So once I remember that, you know, how I stuck this in my mind. So once you project the shadow, right, and then so you define cosine of alpha as S divided by L. Okay, this is the cosine of alpha. If it's complementary, is also the sine of beta. And then the sine of alpha is L sine, you know, the other way, this other side. Sine of alpha equal, or this, I don't know, repito, right? I should have used the same letters. This is H, this is B. So B is H cosine of alpha. So the cosine of alpha is going to be B over, what am I talking to? What I'm trying to do? I'm so tired. Why am I trying to speak? You know, it's part of my system to face stress. You know, not feeling stressed before every class. So being overexposed to teaching, but I just can't. I'm super tired. I wanted to go to bed, and then I remember that I didn't record myself. I've been recording myself for 15 days on a row. And at first I tried to say something interesting, but now I know that that's horrible what I'm saying. So, yeah, I think it was one of my worst nightmares. Explaining things that I don't care, you know? And I felt like that when I started teaching university, you know? But I had to do it. So, if I had to explain, I never explain this to my students. I only try to remember this to understand things that are kept in my memories, like this. So L is not L. So now H times sine of alpha is equal to A. So sine of alpha is A divided by H, which is the same of cosine of beta. That's the only way I can think of to remember the trigonometry, because I didn't really understand. I didn't really understand why it's used. At least I could understand this palm tree example, where I can see that the shadow is somehow related to the angle, because if you change the inclination of the, you know, the tilting of the palm tree, the length of the shadow changes. Okay, this is a different angle, alpha prima. Even though the length is the same, this shadow is different because the angle changes. So that's how cosine it was introduced. A relationship between, in a rectangular triangle, how do you call it? There's a function that was introduced to relate the length of the palm tree, inclination, and the size of the shadow. That's how I understand. For the sine, I don't understand. I never understood sine, you know, because I don't see any application of sine, you know, like, yeah, but you can see, yeah, but if you have the shadow, the height, the you know, from this ground, from the ceiling, you know, from the floor level, this height is how you call it with the sine. Okay, good. How tall is this tree? You mean the length or how tall, because it's tilted. So the sine is how tall is the fallen tree. I mean, we face one problem that I didn't want to, I didn't expect, is that the way I was taught this was using memory, not understanding. You know, it's all these equations, and we are lucky. I'm lucky that I found a way to remember which was the sine and which was the cosine, because for years I didn't know, I didn't remember. So how can you remember things you don't understand? There are lists of things. I had to study so many lists of things in my life that I forgot. That's a problem. At least I found this, but yeah, it's horrible. So why the sum of I remember the proof, the sum of the angles of, yeah, I remember that you have to do something like putting several triangles together or something like that equal. It's horrible. That's horrible. Why alpha plus beta plus gamma is 180 degrees? I think this is how it was defined, 180 degrees. Yeah, but there's no intuition in there. I think let's try to figure it out, and then we start with this, because this is bullshit. Bullshit, I admit. That's so many years of my life doing this, and it's such a waste of time, don't you think? Okay, let's try to see at least yeah, the Pythagoras theorem. I know how to prove it because I saw it in a museum. Here in a museum. Let's start with the Pythagoras, and then if I can do this alpha, beta, gamma. The thing about the areas, it's okay, but it's not intuitive. I remember in a museum there was this rectangular triangle, okay, and then this length made a cube. This length was used to make another cube, and you have cubes, okay, and this, you use this length to make another cube. I remember this figure was how did they do it? They filled in a square. It was flat, and then this filled with water. This was, and it was connected, okay, and this was connected to here, and it was filled with water. Yeah, I remember now. And it was spinning in this direction. So when it was spinning in this direction, at some point this became horizontal, so like this. Was spinning in this. It's horrible mosquito. When it was like that, all the water fell. And it was amazing to see that the amount of water here and the amount of water there filled this container, you know? So that's the idea behind Pythagoras theorem, okay? That the amount of water in a square put there and the amount of water the square put there is just the amount of water that can fill this square, okay? So that is useful. Useful for what? For what? Useful for what? Yeah, so useful. Why is this useful? I don't know. Useful. So the second explanation I had about this Pythagoras theorem, this Pythagoras theorem, I'm trying to figure it out. As long here's what I told you about the ruler, and then the ruler. So if this was 3 and this was 4, 3